Hello, welcome to software testing methodology. So today I am going to discuss about the last topic of unit 4. So second part, last topic, KV charts. So KV charts, so what is meant by KV charts and where the KV charts used and what is the main purpose of the KV chart? The specifications are posted into sentences by using the following if-then format. Generally, we all know well known about that if-then format. If a predicate, whatever the condition we are going to be used, that condition defines the if or predicate, then action will be performed. So KV chart is known by every combination with one of map, chart, diagram. So any mapping functions or chart, KV charts like KV diagrams, all nothing but KV chart. So KV is nothing but corn of which. So they developed this KV chart to find the Boolean algebraic manipulations or expressions. It is used to reduce the Boolean algebraic manipulations to graphical trivia. So this is about the KV charts. Next, here in this KV chart, there are variables like taking the variables like single variable, two variable, three variable. So what is the single variable here? It shows all the Boolean functions of a single variable and their equivalent representation as a KV chart. So see this one. So here we are taking only one variable like A. A is one variable which defines the Boolean algebra like binary digits 0 and 1. So if there is two zeros which defines like one variable for one variable 0, all 0, the function is never true. So it is always false. If there is 0 A, two algebraic functions 0 and 1, the function is true when A is true. So the function is true when A is true. Next, 1 0 means the function is true when A is false. So A bar means A is false, A means A is true. So whenever defines the A naught or A bar, so the function is true when A is false. Next, 1 1, the function is always true. So 0 0 means function is always false, 1 1 means the function is always true. This is for one variable, and by using this one variable we define the KV chart, and this chart is known as KV chart. Next, coming to the two variable. The below diagram shows the 8 of the 16 possible functions of two variables. So 16 for possible functions. So 0 0 like 1, here 1, and here in the 0 0 1, here 0 1 1, and 0 0 at the B side, 0 1 at the B side, or 1 0. So next 1 1, next 0 1 1 1, next 1 0 1 1, next 1 0 0 1 1 0, next 0 0 0 1. So these are all 16 possible functions of two variables. So in whatever the defining variables like A bar, B bar, this is an AND, A B bar and A not B. So A B bar, A is true and not B. B variable not declared means not B. So that is not A B bar. So all this defines like this only, like A bar B, B and not A. Next A B means A and B will be defined. So A defines one variable and here B. So this is the one A B. So A bar B means, so A bar is nothing. So B is defines as true. So this is the two variable. Same like three variables. Two variables means A variable and B variable. So same like three variables. So this is the three variable. So see A, B, C. So this is the three variable, and same as KV charts for three variable are shown in below, and these are all the three variables like 0 0 0 1 1 1 1 0, and C means 0 and 1. So 0 0 1, this is the one variable defining the function. Next 1 0 1, and this if you take this like BC BC 1 0 1 or triple 1. So BC. So all this A bar, B bar, C bar. A bar, there is 0 defines A bar B. A bar B means this is the A bar B, and C which defines C. C bar means 0. If C means A bar B C means here the one will be defined. So this is the three variables. So you all known about this three variable KV chart, like it is in DLD. So in testing purposes, KV charts is mainly specified for one variable, single variable, two variable and three variable. Now next, what is specifications? So specifications for validation procedure. So how the KV chart should be valid and what are the variables, how the variables should be valid variables, all can define in the specification. First one, rewrite the specifications using consistent terminology. So consistent terminology should not be the inconsistent like A, B, C or A bar, B bar, C bar or A bar, B, C bar, so whatever. So every specification need to be performed the consistent terminology. Then it identify the predicates on which the cases are based. Name them with suitable letters such as A, B, C. So identify the conditions. Predicate means conditions on which the cases. So based on several software applications, the cases will be depend on which the cases the predicates will be defined. Name them with suitable letters such as A, B, C. So next, rewrite the specification in English that uses only the logical connectivities. So English means vocabulary using, we are using the vocabulary like and or not. For not means bar, for A bar or B bar, not will use. So that is the way A plus B or A star B, or we are go for A and or and or. So however still it may seem, you all know that. So convert the rewrite specifications into an equivalent set of Boolean expressions. So these specifications like A and B, A or B, A not B can be converted into Boolean expressions like 0, 1, 0, 0, whatever. So that is the fourth step which need to be performed as one of the specification validation procedure or steps. So identify the default actions and case if any required. If there is any default actions to be required, if there is any default cases to be defined in the Boolean algebraic expressions, in that case all the specifications need to be identified. So that is the fifth step. So next to sixth step, enter the Boolean expression in a KV chart. So whatever the KV chart defines, whatever the connectivities performs like and or not, enter that KV chart Boolean expressions in KV chart and check for consistency. If the specifications what we entered are consistent, then there will be no overlap except for the cases that result in multiple actions. So that is the sixth step. Next, enter the default cases and check for consistency. If there is any, so not only Boolean expressions can be checked for consistency, enter the default cases what we have and also check for consistency. So if all boxes are covered, the specification is complete. So total all boxes what we have defining Boolean expression should be entered into the KV chart. All specifications is totally completed. If the specification is totally incomplete or if there is any incomplete or inconsistent, then translate the corresponding boxes of the KV charts back into English. English means and or not, what we have taken as vocabulary, get a clarification, explanation or revision. So and or not, by using these three vocabularies English specification, again we will take that English specifications like A and B, A or B, A not B. By taking that, again enter into that KV charts. If the default cases were not specified explicitly, translate the default cases back into English and get a conclusion. Again, not only in the expressions or specifications, if there is any default cases is defined, so those default cases also can be translated into English and get the confirmation message. So this is 10 specifications in the KV charts. So these are all the mainly specifications which we are using or translating the Boolean expressions or English vocabulary names into Boolean expression, and those Boolean expressions can be entered into the KV chart and the consistency will be checked. If there is no consistency, then again there is a converting translation again into English, and again there is a recheck to be entered into a KV chart. So this is about consistency way to be checked. So this is the way defines the KV chart, and this is the end of unit 5. So hope you all understand about the KV charts and also unit 4, not 5, sorry, unit 4. Hope you all understand about the unit 4. So this is about the KV chart. Thank you.